This is higher derivative. So you don't have to stop at the first derivative. You can keep going. So if they want us to find the second derivative, the first thing you're going to have to find is the first derivative. And so you just take the derivative. That's 3x squared minus 1. And then to find the second derivative, you just continue. So second derivative means derivative of the first derivative. So that would become 6x. And then you can keep going and say, well, let's find the third derivative. And that would just be 6. And there you have it. So first derivative is just the derivative of the function. Second derivative is derivative of the first derivative. And third derivative is the derivative of the second derivative. So how is this used? So here is our application. It says the equation of motion of a particle is given here, where s of t is measured in centimeters and t is measured in seconds. Find the acceleration as a function of time. Well, if we take our function s of t, this is its position. So that is its position. So if we were to plug in 2 seconds, it would tell us where it's located at 2 seconds. So if I hit play here, you can see just that function that we were given is giving its position as time moves. So since we're given a position here, if I move it, you can see it moves forward and then back and then off. And by changing that position, you're adding velocity. And by changing the velocity, you're adding acceleration. So this is what's happening with the object. So our question was, what's happening at 2 seconds? Where is it located? So right there at 2 seconds, we are at 6. 6 what? 6 centimeters. So at 2 seconds, our object is located at 6 centimeters. So as the time goes by, you can see that that distance is changing. All right, and so at 0, we're at 4 centimeters. That's literally its location. And then it goes to the right, and then back to the left, and then off to the right. And you can see it's moving a lot quicker. Well, that's a velocity. So if we take the derivative, s prime of t, we end up with 6t squared minus 10t plus 3, and that would give us our velocity. So if we plug in 2 into here and figure out what that is, so 6 times 4 is 24 minus 20 plus 3, it's 7. So that would be 7 centimeters per second. Where am I getting these units? Remember, our s prime of t would be change in s over change in t. And our s is in centimeters, and our t is in seconds. So that gives our approximation. So they're saying at 2 seconds, it's going to travel at 7 centimeters per second. So at 2 seconds, we're at 6. And then we're going to go at 7 centimeters per second. So 1 second later, we would be at 13. But as you can see, we're at 23. So that means that at 2 seconds, if I can get it back there, 2 seconds, we were at 6, and its velocity at 6, right? At 2 seconds, its velocity was 7 centimeters per second. Then that means 1 second later, it would only been at 13. But yet, when you go to 3, it's 22, which means there had to be some sort of acceleration happening here. So we take the derivative again. So what's happening here is the second derivative is the rate of change in our velocity. And so if you think about it, our second derivative, right, is how is our first derivative changing with respect to that same unit of time? That's what it wants to know. So we're getting centimeters per second per second. So it's centimeters per second squared. And what it is thinking about it this way. If you're doing 7 centimeters per second, and then as the time goes by, you're now doing 9 centimeters per second. So let's say at 2 seconds. In fact, 2 seconds, we were doing 7. And then let's just say at 2.2 seconds, we're doing 9, there was acceleration happening there. And so it increased by 2 centimeters per second per 0.2 seconds. And so we're getting some sort of acceleration off of that. So if we take the second derivative, it's telling us the rate of change in our velocity, and that's our acceleration. How fast are we going? So like, think about it, first derivative is cruise control. You're just coasting, cruising along. Right? And then you have to press the gas pedal. You press the gas and you accelerate. And so what happens is your little speedometer increases. We're getting a change in our velocity. So we're going from like 30 miles per hour to 60 miles per hour, right? That's an acceleration. So it's a second derivative. So if they say find the acceleration as a function of time, they're just saying find the second derivative. So we go 12t minus 10. That's our derivative of our derivative. And then now we can plug in our second, plug the 2 into our second derivative. And that would give us 12. And that would be centimeters per second squared. So there you have it. So taking the first derivative, you get the velocity. It's the change in distance, right? And then you get the second derivative, and that's the change in velocity. So if you're changing velocity, you're accelerating. If you're going from 30 to 60, that's an acceleration of 30 miles per hour. And it took you some amount of time to do it. So like here, we're going from 7 to 9. And that's a 2 centimeters per second increase, and it took us 0.2 seconds to get it, so that would give us our acceleration. Thank you.